welcome back to my channel. So today we are going to do a few sums based on integration. We're going to use substitution method, and these questions had come previous years. So let's start. This is the first question. We have to integrate sine x root over 1 plus cos 2x dx, obviously. So integrate with respect to x. Now, the thing with substitution, why we use it is because when we're going to use substitution, that will help us eliminate one of these. So maybe it'll help us eliminate sin x so that the rest of the differentiation becomes easy. Okay. And why substitution is because we are going to substitute any one of these function with any letter, say m, t, whatever. Okay. And what is the trick? Like, how would we realize what to replace? One of the trick is, so one kind of sum it comes that there are two functions, and one function is actually the differentiation of another function. So that is one way, and we're going to solve all types of sums. So in this case, if you look, we have sine x root over 1 plus cos 2x. You need to be very thorough with trigonometric formulas. So you know that 1 plus cos 2x is 2 cos square x, right? This formula I think you know. So instead of this, meaning I can write this like that. Now, why did I use this formula? Is because there is square and it will help me eliminate the square. Okay, and also because then what will happen? I'll see that sine x differentiation is cos x, so cos x is sine x, so we can replace any one of them, and we'll see how we do it. So I can write this as, so I am actually removing it from the square root. So this will become cos x, this root 2 will be there. Now since root 2 is a constant, then this can come outside. So I am left with sine x cos x dx. So what will I suppose? So I will say that let t is equals to sine x. Okay, let t is equals to sine x. This is the most important part. That means if I differentiate dt dx, what will I get? Cos x, correct? Hmm. Now this is what I'm going. So what I'm going to use. Also, that means dx is equals to dt divided by cos x, right? Cross multiplication, not cross multiplication, but normal linear equation we're using, correct? So now this is what I'm going to do. Write down root 2 over here. Instead of sine x, I can put t, and cos x will remain cos x. Instead of dx, I can put dt by cos x, because using this only. So this cos x gets eliminated. So what I'm left with is root 2 t dt, right? Now integration of t is what? Integration of t is root 2 t square by 2. If you differentiate this, you will get root 2t by 2, because 2 is there. So this, basically I'm using the normal formula plus constant. Now t, what was t? Sine x. So I can write this as root 2 sine square x by 2 plus c. So you can cancel this 2, those 2 get root 2. But this is going to be your final answer. This. Okay, and this is how we use substitution method. So make it in such a way, bring it in such a way so that one becomes a differentiation of another. This is one type of sum. Similar to this, let's look at this sum. Sine tan inverse x 1 by x squared. As I told you, need to be really thorough with the trigonometric formulas. This is a very easy sum. It just had come in previous years. I'll just, yeah. Okay, right. So you already know this one thing, that tan inverse x ddx is 1 by 1 plus x squared. We know this. So what I'm going to do is I'm going to use this formula only to solve this sum. How am I going to use it? Let us see. So I will say that let t is equals to tan inverse x. As I told you, we have to substitute any one of these. So always substitute a more complicated part. And why am I writing t is equals to tan inverse x? The reason is because I know that when I'm going to differentiate tan inverse x, I'm going to get 1 plus x square. So dt by dx becomes 1 by 1 plus x square. So dx becomes dt 1 plus x square. See, now if I, now I'm going to replace this, instead of dx I'll write this. So this means 1 plus x square, and the denominator will get cancelled. So okay, now as you know, I uh, substituted tan inverse x with the letter t. So I can write this as sine t by 1 plus x square, and instead of dx I will write dt 1 plus x squared, like how I did over here. This is important. This is the most important thing. This and this will get cancelled. So what I'm left with is sine t dt. So what is the differentiation of sine t minus cos t, right? So this becomes minus cos tan inverse of x plus c. This is going to be your answer. So all formulas of integration you should remember. Next question is this. X plus 1, this is your question. Now, as I've told you, always take the more complicated part as your substitution. So here, this is very important, so pay extra attention. I will say t is equals to x plus log x. Okay, that means dt by sorry, if I take t is equals to x plus log x, and see there is a square, so I will square it. So I will square it only. No, I will not square it actually. Let's keep it this only. So t equals to x plus log x. Okay, correct. So that means dt by dx becomes 1 plus 1 by x, right? Now here's where it becomes a bit complicated, because you don't realize what should I take as t. Should I put it as t square, or should I just let it be t? So the better thing to do actually would be to make it as t square. Okay. So if I put it as t square, let me put this as t square only. X plus log x whole. I shall leave it. Dt by dx becomes 1 plus 1 by x. So now what I'll do, I'll replace this everything over here. Let's say x plus 1. This becomes t square by x, and instead of dx, let me solve this further. Oh, it'll be very easy now, right? Dx becomes dt into x by x plus 1. It'll become very simple now. Dt x by x plus 1. So what happens is x's cancel, x's won't cancel. So we're left with t square dt, which is what, t3 by 3 plus c, and t I had taken as this. So instead of t, I will just write x plus log x whole cube by 3 plus c. This is so easy. This is going to be your answer. Next question is this one. Okay, 1 plus tan x and this. Now, if you in these kind of sums, always take the denominator as t. Okay, t or any other letter you can take, but always take that, especially when you see that the differentiation of the denominator is the numerator. So if I differentiate x plus log x, I will actually get this 1 plus tan x. So see, t equals x plus log sec x. Okay, dt by dx is what, 1 plus log sec x is 1 by sec x into sec x tan x, right? Cancel, what do I get? 1 plus tan x, and 1 plus tan x is the numerator. So let me write this as, and dx dt by dx, so replace d means put dx as subject, becomes dt by 1 plus tan x, right? So that's what I'm going to do. Dt by 1 plus tan x, cancelled. So what I get, 1 by t dt, 1 by t is log t plus c log x plus log sec x plus c is going to be your answer. Next question, this one. So you need to know a bit of trigonometry to solve this. Tan x is equals to sin x by cos x, right? There are two ways of solving it, two ways. One way is to use this thing, tan a plus b. Basically, tan pi by 4 plus x you can use, because then you're going to get tan pi by 4 plus tan x divided by 1 minus tan pi by 4 plus into tan x. So basically this thing you can write together as tan pi by 4 plus x, and then you differentiate this. For this differentiation also a bit of complications will be there, because there is no direct differentiation of tan x as such, so don't do this. What you can do is actually replace tan x by sin x by cos x. Okay, so that's what I'm going to do. See over here, and this will actually make it so simple. Let me show you now. See what I'm doing. Do you agree with this? What have I done? Basically cross multiplied and then cancelled the cos x. So now what you can do is, sorry, just 1 minute. Now I can replace the denominator with t. Correct? So t is the numerator I think we should replace by t. So t is cos x plus sin x. dt by dx is minus sin x plus cos x. Correct? Hmm. This is what we're gonna do. So dx, making dx the subject, we get what, dt by sin x plus cos x, and also a negative sign, don't forget. So I'll put this negative sign behind, replace this as t by cos x minus sin x, and dx can be written as dt by, hold on, no, oh, wait, I think I made a mistake. Yes, no, so sorry, this is what happens. We actually cannot do this. The reason is we have to make the numerator as t. Wait, cos x minus sin x. If I put dt by dx, if I do, then I get minus sin x minus cos x. Yeah, sorry. This is only what we're gonna do actually. So I can write dx as dt divided by minus sin x plus cos x. Correct? Never replace the numerator as t. Don't do it. Replace the denominator as t. Because why so? Because then dt by something will be there. So two denominators you cannot cancel, but you can cancel the numerator and the denominator. See? So cos x plus sin x divided by this t placed as t. This will become dt by sin x plus cos x. See, what I did was replace dx with this, and this minus sign I just put it behind, and you can put numerator, denominator, anything minus. Cancelled, cancelled. I have minus 1 by t dt, which becomes what, minus log t plus c. Replace t with whatever we had taken, and that will become your answer. And I think I did this mistake so that you don't do it in your exam. Don't replace the numerator as t, replace the denominator as t, differentiate it, you will eventually get the answer. Next is this question. So, this is actually a very interesting question, it's very important also. Okay, here, as I told you, if any complicated sum comes, always replace the denominator with t. t. So t is equals to a square cos square x plus b square sine square x. Now dt by dx becomes what? Since this a square is constant, so this is going to be there. This will be 2 sine x, negative sign, uh, and then sorry, this will be a square 2 cos x into a square is constant, so it will get out, means come out, and then cos square x differentiation is 2 cos x into minus sine x, so I'll put a minus sine x and I'll write. Similarly, square sine x differentiation is 2 sine x into cos x, right? Now look at this equation carefully. A square 2 cos x sine x plus b square 2 sine x cos x. Can you see that this and this term matches? So if I write b square minus a square and I write this, is it a problem? No, it's not a problem. And remember, this is actually dt by dx because this is the numerator's differentiation. And if you carefully notice, I can replace this as sine 2x because the formula of sine 2x is 2 cos x sine x, and sine 2x is our numerator. So let me write this sine 2x divided by t into, instead of dx, so dx will go here, this will come down. So this becomes dt divided by b square minus a square sine 2x. Correct? This get cancelled, and this is not a problem because since it is actually a constant, it can come out. 1 by t dt become, which means 1 by b square minus a square into log t plus c, because 1 by t is integration is log t. Whatever we had taken as t, put it here, and that's the answer. Next is this question. Now this is actually homework, but I wanted to have one question having e. So here obviously I'm going to replace this only. T is e root over x, so dt by dx. So we'll be very careful. This is x to the power half minus 1 and half over here. That means what? 1 by 2 root x. So put e to the power t by root x. Okay. Now dx is equals to dt into 2 root x. So right over here, dt into 2 root x, cancel this, get 2 e to the power t, which is same e2 e to the power t plus c, 2 e to the power, what had we taken as t root x? Let's see. This will be your answer. And you're going to do the same thing here. But instead, I'll give you one hint. E to the power x to the power 3, what do? Replace this whole thing as t. Okay, and then solve it, so it will become very easy. Okay, then what will happen is that this will become, if you differentiate c dt by dx, will be e x to the power 3 into differentiation of this will become 3x square. So if you replace this, make this as the subject, replace, then this x square and this x square will get cancelled. This will become cos dt and everything will be very simple, it will be easily cancelled. Okay, and also this e to the power x will also get cancelled, so all you're going to left be with cos t dt. Okay, this is how we're going to solve it. Two more homework sums. These are the sums, again very simple. Okay guys, so that is it for this video, and I hope you liked it. Bye.